Hello. We will be explaining and differentiating the chi-square tests for homogeneity and association or independence. The purpose of a chi-square test for homogeneity and association or independence is to determine if distributions of categorical variables are the same for different populations or upon the implementation of different treatments. To start, we need to determine in which situations to use the chi-square test for homogeneity or the chi-square test for independence. So how should we do this? In order to identify a chi-square test for homogeneity, you should look out for the presence of one categorical variable and two more distinct samples. A chi-square test for homogeneity tests whether different samples concerned with one categorical variable have the same distributions. Having one variable and two or more different samples is a clear indication of a chi-square test for homogeneity. To identify a chi-square test for independence, you should determine if the test involves two categorical variables concerning one sample from the population. A chi-square test for independence tests if one variable is independent of or not associated with the other in a single sample. So for examples, Example 1. Market researchers suspect that background music may affect mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments: no music, French recording music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. So, in this case, which test should be used? This would require a chi-square test for homogeneity, and we can tell since in this case data is sampled multiple times, once when playing French recording music, once when playing Italian string music, and also when playing other types of music. Now for example 2. A study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. This includes people who had heart attacks and those who needed medical treatments for heart disease. Here is a two-way table that summarizes the data. Now, would this require a chi-square test for homogeneity or a chi-square test for independence? Well, this would require a chi-square test for independence because we can see that in this case, data for two categorical variables is collected from one sample. Now, in order to solve a chi-square test, you should answer the question in a state, plan, do, conclude formula. So for the chi-square test for independence, it would go something like this. For the state, you would have to state a null and alternative hypothesis. For the null hypothesis, you'd state it in this general form of, there is no association between the explanatory variable and response variable. For the alternative hypothesis, you would then say that there is an association between the explanatory variable and the response variable. For the plan, you would need to state that you would be conducting a chi-square test for independence, and you would need to make sure that the conditions were satisfied. The conditions are that the data must be randomly sampled. If sampling without replacement, make sure that the data comes from less than 10% of the population, and to make sure that all expected counts are at least 5. For the do step, you'd use the equation with this formula. And then you'd also figure out the degrees of freedom using this formula. For the conclusion, you'd follow the form of, since the p-value is large or small, we fail to reject the null hypothesis. And then you'd go on to state that we do not or do have convincing evidence that there is an association between the explanatory variable and response variable. For homogeneity, the form would be quite similar, except for the null hypothesis, you'd say that there is no difference in the distribution of explanatory variable and response variable, and for the alternative hypothesis, you would say that there is a difference in the distribution of explanatory variable and response variable. The conditions are the same for both, and the method of solving with the equations is the same for both as well. For the conclusion, however, there is a small difference. You'd state that since the p-value is large or small, we fail to reject the null hypothesis, and that we do not or do have convincing evidence that there is a difference in the distribution of explanatory variable and response variables. Now, to solve this, it would be beneficial to try to use a calculator in order to try to minimize mistakes. So you'd essentially input your two-way table into a matrix, and then you go to the stats part of your graphing calculator, and you'd find the chi-square test. You don't need to worry about the expected thing as long as you entered your observed data into matrix A. Then you can click calculate, and all your values will be there. However, it is important to remember that during the AP stats test, you should include the name of the procedure, which would be either the chi-square test for homogeneity or association or independence, and to report the test statistic, the degrees of freedom, and the p-value. Now, if you want some practice for how to solve a chi-squared question. Try question 4 from Form B of the 2011 AP Statistics test. And to end, I just want to say good morning, and in case I don't see you, good afternoon, good evening, and good night.